Hello everyone, I'm Anshul Lodha and I'd like to talk more about the application that I've developed. I've developed this application using HTML, CSS and JavaScript. This application has been programmed based on MVC architecture. This application is hosted on a server, so all you need to do is just go to this URL to access this application. This application has two major capabilities. First, it can simulate n-bar mechanisms, and it also can synthesize 4-bar mechanisms. Let's start with the synthesis part. Now, the options you see over here is a dynamically expanding menu. I've implemented this menu so that all the similar options are clubbed together. Now, if you hit on the second option, you do see it expands and shows all the synthesis options that can be used for synthesis. Let's try synthesizing a 4-bar mechanism. All I need is this position constraint, and I can have 5 positions and get a 4-bar from these 5 positions. Now I do see that this 4-bar passes through all these 5 positions. All I need is hit play and see this mechanism moving. Well, I can also create a 4-bar mechanism with 3 position and 2 fixed pivots, that is 2 point constraints. I have these 2 point constraints and I can synthesize a mechanism. Well, what I see right now is that there is no such mechanism available. If I change one of these points, I can have some mechanism. So let's see if this point has some mechanism. Or maybe change angle of some of the positions to see if there is a mechanism. Yes, we do have a mechanism. You can just scroll or pinch zoom to zoom in and zoom out and play to see the mechanism moving. Now let's talk about the simulation part. We can change these circuits or the branches from red to yellow curve by using these buttons. So if you see, these change branches and circuits. I can draw a 4-bar as well. Let's clear this canvas and I can go to this button and expand the simulation menu. I can draw a 4-bar by just click and drag, and I have a working 4-bar over here. All I need to hit play button and see this 4-bar moving. Now what if I have to make up a 6-bar or 8-bar or a 10-bar mechanism? Well, you can do that. Let's say I have an image of a walking mechanism and I need to draw exact same mechanism. However, I do not have the dimensions. All I would do is go and import that image. So I can click on the image button and get that image, which is, let's say, Theo Jansen image. Now I can see this image a bit smaller and a bit difficult to draw a mechanism over this. So all I would do is click on this image and then I will see the contextual option coming in. So as soon as I click on this image, I will see these 2 options showing up where I can scale this image, move it to the center or wherever I like it to be, change the opacity, and then start drawing the mechanism. Let's try drawing this exact same mechanism over this. I can go over until here. I can start a fixed joint. Now I need to convert this link number 4 into a ternary link, that is a link having 3 joints. I do see a button coming up over here, so I can use this option, hit on 4, and I do see that this has been converted. I can again select the RR link option and continue drawing my links. So I can draw 1, 2, and just complete my mechanism. Now one thing you might have noticed that as soon as I start, as I go towards the end of some other link, this automatically snaps. So you see, this automatically connects all the links. So all you need to do is just click and drag. The rest will be taken care of. I can again convert this link to a ternary link and get the coupler curve of this point which is shown over here. I can just hit plot curve from this option and we can see a curve coming up over here. If you move this point, you can see the coupler curves updating in real time. Now if you take the exact same dimensions of this mechanism that have been shown, you will see the exact same curve that will be traced by this mechanism. I can just hit play and I will be seeing this mechanism moving. Well, I can change the RPM of the moving joint as well. All I need to do is click on this joint and I will see the relevant option coming up. I can then hit, say, 50, enter, and play. I have changed the RPM. Now let's see what all options do we have. So let's say I have created this mechanism and I need to save this mechanism. How do you do that? Well, all you need to do is go to the menu and click export. As soon as you hit export, you have options like XML, text, PDF, and GIF. XML and text are the file options where you can export your mechanism into a file and then share or save that file for future purposes. You can export your mechanism as a PDF as well. When you export as a PDF, you generate essentially a report of the mechanism, and one can manufacture the mechanism by just looking at the PDF. So let's have a look at the PDF, and this is something it will look like. This has annotated the mechanism. We do have the joint information, the link information, the link angles, and all the relevant information required to basically manufacture this mechanism. We can also create GIF files. All you need to do is hit GIF, and this takes a little bit while converting into a GIF file, but you don't need to wait while looking at this application. You can just go hide and it will hide itself with this little animation and continue the process in the background. So it really does continue the process in the background. All you need is just hide and keep working. Let's see when the GIF gets converted. Now let's clear this canvas and try importing a mechanism. So if I have import, I can import this XML file and see a mechanism is imported. This is how simple it is to export and import a mechanism. As long as you have the proper files to export and import, the mechanism is super easy to import. I can export this mechanism as a text file. Now let's export this as a text file and see how does that text file look like. As soon as I hit open on this text file, I do see that this is rather a user readable text file where I see the poses, the joints, so the coordinates of all the joints and the coordinates of all the links. So this says that joint first is from this point on this point, the second joint is this point, and first link goes from joint 1 to 2 and has this color option. This is a user readable format, so you can actually create a text file in this format and import and get your mechanism. Trust me, this is the most important thing, and this is the most important feature that you will enjoy while using MotionGen. Let's see about downloading the GIF file. Now the GIF animation has been complete and he's asking me to save the GIF animation. Let's save it on the desktop and hit open. Now I do see a moving animation that has been created by this application. Looks beautiful. I can hit close, and these are all the export options. I do have some more fun options to be, which are like changing the color of your links. You can just hit any color and change color of your links and create colorful linkages. You can hit on a joint to change their coordinates from some values to other values which you desire. You can as well click on the driving links to change the direction of rotation of the motor so that you have animation going in the other direction. Now let's try simulating a multi-degree of freedom mechanism. Say I have this 2R manipulator and I need to attach one more motor at the second joint. Well, I can do that. I just need to hit and say add input. As soon as I see add input button, I know this application has recognized that this is a 2 degree of freedom mechanism and this is the place I can potentially add input for. So this is a eligible candidate for adding a new motor or adding a new input. I can add input and then I can see there are 2 motors and 1 simulation. one way in which this mechanism basically moves. And I can have a look at the simulation by hitting the play button. We do have some canned examples in case you want to have a look. It's like what 6 bar mechanism. You can have something like 10 bar gripper. So this is a 10 bar mechanism which has a gripping action kind of thing. We do have some fun examples, which is a smart bird, and you do see that this is a mechanical bird which is flapping its wing just by rotating one motor. So you have one rotor and a lot of bird flapping motion coming into picture. Now, as well as these features, you can adjust settings like the display grid, the link numbers. You can have a kinematic view of what is being shown, so you can just hit kinematic view and you'll be shown with a schematic diagram of what the mechanism is to be. Alright, thank you so much for bearing with me. This is all about MotionGen.